Whoa, okay. So I'm going to introduce the next panel. And this is interesting because, you know, it's a panel about the development of the Arduino platform itself. And so we thought we were going to, bring on stage also some of the people that actually build the code that runs in all of your Arduinos, along with some amazing guests. So, well, first of all, let's bring on stage the person who's going to run this panel, Martino Facchin, also known as the Embedded Emperor. So he's a multi-talented developer, and so have a seat, and then I'll let you introduce the rest of the panel. And it's gonna, if you're part of the Arduino community, maybe just get on Twitter or some other chat and start asking questions, because some of these people are the actual people who build Arduino, so they're the best people to answer questions. So I'll let you introduce the rest of the panel, and I'll.
Thank you, Massimo. And I'm very, very, very happy of being here, and thank you. The first thing that came to my mind when they asked me to run this panel was Steve Ballmer jumping and shouting developers everywhere, but I will not do this, so let me introduce.
You have a blue shirt like this.
Exactly. Let me introduce my guests. So we have Cristian Maglie, a senior developer at Arduino. Federico Vanzati, which is now in charge of manufacturing, and is one of the first employees at Arduino. And Adrian McEwen, who runs a company, MCQN, which produces IoT devices, and is also a long-standing Arduino contributor. He wrote the first Ethernet library. And we have from San Francisco, probably, Anjali. I don't know if she's joining us. Let's wait a couple of seconds. No? Okay. Okay, let's start without her, and I hope she will join. She works at Intel, and anyway. Okay, we can go, I believe. And okay, we are developers. We like programming languages, we like programming. This is something we do for work, but also we enjoy coding. And Arduino, it's a language which naturally takes you to enjoying the start of coding and how to learn coding. And then from there, you can start doing some other stuff. And when Arduino started 10 years ago, choosing C and C++ was probably the only choice, because microcontrollers were small. Oh, maybe Anjali? Almost there? Okay. And so choosing C and C++ was probably the only intelligent choice. But nowadays, microcontrollers are much bigger, and they are plentiful of memory and flash. So if you could choose, would you like Arduino to adopt officially another language, maybe easier for beginners or more targeted to professionals, or do you like the actual situation?
Okay, I think that the question should be if the new language we should basically on Arduino. I think the most important thing is that all the legacy that we have in Arduino. So besides the language used in Arduino, we have to think that if someone wants to make something working on Arduino, he surely can find a library or a software already done for doing that kind of thing. I mean, usually if you need to connect a sensor to Arduino, you can easily find a library already done for that kind of sensor by searching on Google the name of the sensor, space Arduino. No? So I think that if we want to introduce a new language, a more simple language or a more modern language compared to C++, we have to think also all the heritage that we have on Arduino. So maybe when introducing a new language, I think that an important thing is to make a bridge. No? So the new language could be used with existing libraries. So I think this is the most important thing for. Personally, I don't have any preference for new languages. Another thing that I would consider in choosing a new language is the complexity of this language. You know? As a developer, I think that, like many other professional developers, we like to languages with complex features like functional programming or templates or any kind of fancy feature that makes the language more complex. And I think one of the advantages of Arduino is that it's even if it's based on a complex language like C++, the libraries are made simple for people to use. I think this is an advantage of Arduino.
Thank you, Cristian.
Yeah, I agree with everything that Cristian said, but I want to add that maybe there are people or some other developer that come from different approaches, like, for example, web development, so JavaScript, so they are more used to asynchronous programming, and then on a microcontroller you have, for example, in Arduino you have a loop, so it's a monothread looping function, and maybe so if you come from JavaScript you have some trouble and you need to figure out and a part of understanding how to develop a code in C, you have also to change the approach. And also maybe people that comes from Python, that it's also quite common in schools, and you have some cool math libraries. Maybe they want to approach to Arduino, but some high-level math or filter libraries. So maybe experiment something and try to glue everything to Arduino could be interesting. Also because I see that Arduino is something that sits in the middle. So on the bottom you have bare metal programming, hard stuff for engineers, and on the top you have simplified or simple syntax languages, and yeah, so Arduino could be easy or too hard to understand, depending from which part you look.
It's just good to be in the middle in this case.
yeah, we are in the middle, and we are open to any possibilities or any cases. Or like Cristian said, there are tons of libraries, so you can do a lot of things, but not everything.
Thanks.
I think that's one of the things with Arduino, though. It's like it's created like however many hundreds of thousands of C++ programmers who don't realize that they're C++ programmers. Like it made a few little changes to make C++ more user-friendly, and suddenly you've got loads of people programming and building things that they couldn't build otherwise. Like without realizing that they're doing C++, they think, oh, I'm doing Arduino, and you go, well, it's C++ really. and it's always difficult to work out. You know, everybody has their favorite languages. There's a lot of push at the moment for Python, at least in the UK, that I see with kind of education stuff. And people are running Python on, or MicroPython on similar boards, like on the sort of Arduino level boards, but you still hit the same problems that you hit with the C++ stuff, where you're on a limited platform and like things are different. It's a tricky problem to try to solve, I think. I mean, I'd argue in some ways we worry less about the language and, you know, the Arduino environment, as Cristian says, there's loads of libraries. Lots of people can help you kind of get up to speed with it, and people learn more than one language. You know, I've been programming professionally for far too long, but you know, I've written C, C++, Python, Ruby, like, you know, playing around with some Rust stuff recently. Like, the more languages you learn, the more languages you can kind of understand, and the more concepts you have to grasp hold of and kind of pull into your coding to do stuff. So, like, it would be good to find ways to draw more of the web community into the Arduino kind of world. I mean, there's a massive overlap at the moment already. The number of web developers who play around with Arduino projects on the side is huge. So maybe we just need to find ways to kind of help them bridge that gap, but not spend all our time apologizing for the fact, you know, it's C++, like, but that still lets you do that. You can use, you run out of memory, for example, like, less frequently, because you're doing stuff that's a bit tighter and smaller, and that means you can build more complex things. And maybe you start with some stuff until you hit the limits, and then it's like, okay, I need to code this in C or C++, or you know, the tight timing constraints you have on hardware programs, like, it's easier in C because it's not going to go and garbage collect on you, like in the middle of doing some really critical timing thing that you had to get right. So it's a challenge to work out how we get a load of web developers to be embedded developers, and there's also a challenge of how we get some of the kind of old school embedded developers to understand the internet and IoT and things like that when you're kind of connecting stuff up, because that's a whole different set, you know, different challenges, but it's a hard problem to solve, I guess.
Yeah, that's hard. But yeah, talking about C++, if you adopt this language, you get for free support. For free. You have all the platform that can be potentially supported, and Arduino, in fact, is being supported on a huge amount of platforms. It's something that blows my mind every time I think about it. We start from ATTiny's with 0.5 kilobyte of flash, and we get to Core i7s recently, and you can write Arduino code on all these platforms. So a lot of these cores, we call them cores, we wrote them a lot. The majority has been written by the community. So the thing I wanted to ask you is, which is the platform in which you prefer coding in Arduino? So which microcontroller do you like most?
Well, to blink an LED, my preferred controller is a Core i7. No, I think that the question is the nice thing about Arduino is that you can change platform almost seamlessly. So the real power of the Arduino platform is the Arduino API, that are the interface when the function that you write on your code to do things in Arduino. No? So you are basically 99% sure that on each platform you can find a function called, for example, digital write or serial to print on the serial monitor. So one sketch that you made for one platform, it's easily portable to another platform. This is the real power of Arduino. It's the Arduino API. What is lacking now in Arduino is missing formal definition of this API. So it's a de facto API. No? Everyone implements it, but nobody has defined it formally. So Massimo announced some weeks ago a project called Chainsaw. The reason of the fancy name is because this project aims to create a formal definition of the Arduino API. So basically, we take the implementation of the platform at so, no? And basically we split the implementation that is architecture specific from the real API. So basically, we are in a way defining the Arduino API because there are differences between each implementation of the Arduino API for each platform, small differences. Making a formal definition of the Arduino API will help us to remove these differences between the various platforms and make the code more portable between them.
Thank you, Cristian. And we have Anjali live from California, probably. Can you hear us?
I can. Hello.
Oh, ciao. And okay, just let me. I don't know if you heard the question. Okay. No, it was about the fact that Arduino is now supported on a huge variety of platforms, and from ATtinies to Core i7s, and which one do you prefer to work with and to code with, and why?
Oh, that's a good question. Yeah, there are so many boards in the market right now, and my personal favorite is the upsquared board, which I get to work on also. So I think it's one of the fastest x86 maker board right now, based on the Intel Apollo like platform. And it's my board of choice because when I'm prototyping, it has basically everything. I can hook up a monitor, I can hook up a keyboard and just develop directly on the board itself. And I like to have that flexibility. And when I'm not developing directly on the device, I have the option of developing using a cloud IDE like Arduino Create, or maybe using a System Studio, a desktop-based IDE. But then I also have the option to go from one to the other. And I like to have that flexibility because it means I'm not, tied to one manufacturer or one service provider. And there is a way to connect between the two IDEs. Basically, I can port my libraries and sketches from Arduino Create to System Studio, and Arduino Create exports all sketches as CMake projects. So essentially, any ecosystem that works with CMake will be good for my project. So, but as you asked, for board of choice, it's upsquare right now, and I know there are some exciting boards coming into the market, so we'll have to wait and see what it is in the future.
Thank you, Anjali. Fede?
Yeah, for my personal experience, so since I'm looking after testing and manufacturing, so I'm testing new boards, so prototypes and manufacturing test rigs. And thanks to you guys, I'm able to use Arduino as a tool for developing the testing tools too. So I can build a logic analyzer, a data logger for long run tests. We are also running the manufacturing test rigs on Linux embedded boards, and we are porting the code to the Arduino lib. So everything is developed using Arduino tools, and
we are producing the boards, the Arduino boards, using other Arduino boards.
Yes, it's Arduino making Arduino boards.
Arduino making Arduinos.
Yes, of course. Cool. Yes, and also maybe if I want to, when I don't need a specific test equipment, Arduino it's always the right tool to start develop something to automate tests. So when you start doing something repetitively, or you have specific time to to respect, to achieve. It's when you start using an Arduino, and maybe you start with one board, and maybe you end up doing a logic analyzer on top of a Linux board. So you start from an Arduino Uno, and then the same code runs on a most performing platform.
Thanks.
I don't think I have a favorite Arduino board. Like, that's the benefit of the Arduino platform, is that it runs on so many different things, and because it's open source, we then get it on loads of other platforms that aren't just the ones developed by the core Arduino team. And so it depends what problem I'm trying to solve. You know, if I'm just doing something really simple and like almost on the level of flashing an LED, then I grab an Uno, because there'll be one sat at my desk somewhere, underneath a load of other boards probably, but you know, my desk's really messy. And then if I'm developing other things, like a product I'm developing at the moment is using Wi-Fi, and so I'm using like the ESP8266 because that's super cheap. But I'm still using the Arduino IDE, and the Arduino, my code kind of ports pretty seamlessly across. You know, there's some little changes I need to make here and there. When I was driving like 60 meters of NeoPixels on a Christmas tree in the center of Liverpool at Christmas, like then I was using Teensy, because I ended up with 4 Teensies, because there's a really good library for Teensy to drive loads of NeoPixels. And so you're picking the problem that you've got to solve and kind of deciding, okay, which of these boards is going to make the best, and you don't get the perfect match, but you get something that you're like, well, I've used these before, and this is going to solve the problem because I can use that library, I can work with that bit of, you know, there's that shield that fits on it, or just I've got one of these on my desk right now, like the best Arduino is the one that's nearest to hand when you need it, maybe. Like, but that's just the benefit of the platform and the community, is that there's so many people building boards, working out how to hook them into the IDE. You can take your software and get it to run on a new board like really quickly. Like the Teensy I hadn't played with before Christmas, but I didn't have any problems with kind of deciding to buy and use it in that project, because I'm like, well, it's an Arduino board. I know my way around that. There'll be a load of familiar things there, and then there'll be some little tiny learning curves with, you know, how I get the actual code onto the board itself. But, you know, it's, very much, what's the project? What's it trying to do? You know, what network technologies is it going to use? Like, there's all of the nice new kind of the Sigfox and LoRaWAN, and if you wanted to do really low power, low bandwidth sort of stuff, then you know, you pick one of those boards. Like, and it's, definitely the problem you're trying to solve, and then the board that's appropriate, because there will be one.
Thank you. So we have a lot of boards, a lot of different technologies, and a lot of different communication medium. So this is IoT, in fact. And one thing that in the Arduino world has never been a first-class citizen was security. So we always treated security like, oh, okay, it would be really nice to have SSL, but we didn't have the resources on the chip to handle SSL. And for example, now we can do it. So do you believe, Adrian, it's for you. Let's reverse a bit. But do you believe that we should introduce this very difficult problem, which is security, to our user, or should we hide it as much as possible? How can we handle it in the Arduino way?
I think that, as you say, in the Arduino way is kind of an interesting one. We need, like, security is a massive thing we need to do in the Internet of Things. And like, mea culpa, I was looking after the Ethernet library. It's partly my fault, I guess, because we were, you know, when I was introducing that, or working on that, like 10 years ago, it was running on Atmega 328s with 2K of RAM, and it was still not long after the 168 was still, you know, it's like, so have you really got 2K of RAM? Maybe you've only got 1K of RAM. And I always wanted to put some of the security stuff into it, but when you've only got 2K of RAM, it's like, how do you do the buffer for your, you know, kind of encryption stuff? Because you're going to need to write the encryption code into it. You might need like a couple of kilobytes of RAM to do that just as a buffer. And like, well, there's all of my memory gone. But these days we're running on kind of, you know, the microcontrollers generally, the kind of, I suppose the base level slowly shifting towards kind of the ARM Cortex-Ms, which have then got enough memory that you can start to do these sorts of things. So we need to have it baked in, and it needs to be the normal. Like, we need the examples to be just, it's as easy to connect to a site with HTTPS as it is to connect to a site with HTTP. Like, so when you're a beginner just coming along and you're using the example, and you're like, okay, I need to talk to this website. Oh, I just use this secure one. Cool, right, it just works. I haven't really thought about it. And that's not going to give you all of the, there's more to security than just using HTTPS. But if we can just start to raise the bar of like the bottom level of like how secure things are, then that's going to get us a long way. It's going to be a continual journey. And one of the things that hopefully the Arduino stuff will do really, the Arduino team and Arduino as a kind of an ecosystem has always worked really nicely to draw people and make things easier for them to grasp and start to use. And so we need to start doing that with security, so that then just like, all of these kind of random instructables that are around on the web or something to do, like this cool thing, like suddenly it's a secure cool thing as well. And that'll be like a massive step forwards from where we are at the moment.
Thanks. Anjali, from your experience with Linux-grade machines, what do you think about how we could handle security in the Arduino way?
I have worked with developers who are very concerned about security, and with developers who, they just want to get their work done, and they don't really want to waste time, so as to say, in making the code secure. As people who work in developing the ecosystem that other developers use, I think it's our responsibility to provide them the tools or the infrastructure needed to ensure that their code is secure as well as quick. And I know Arduino is trying to do that in a couple of ways. I was just looking at the secret tab we have in the Arduino Create Cloud IDE, where you can provide credentials when using libraries for the IDE for your particular sketch. But when exporting or sharing that sketch, the secrets don't get shared. And it's a very, thinking from the perspective of a developer, it's a very easy fix. It's just a header file that gets displayed nicely to the user. But for a new user, having that ability makes security doable. So I think the goal of the Arduino ecosystem should be to make security doable and not make it too easy. So finding that right balance where it's safe but not hard is the key.
Thanks. Cristian?
Okay, I totally agree with Anjali. It's finding the right compromise. In Arduino, we always fight with developers that want more flexibility from our libraries. More flexibility means more option to the end user. Instead, the end users want just something that works, without tweaking too much, because maybe having a building blocks that needs 15 knobs that needs to be put in the right order, it's not that usable, no? Maybe you just want something that you put and works. And so we are always facing this kind of balance, no? And it's a recurring problem in Arduino. Not only for the libraries, but also for the IDE, for the also the API of the core, etc.
So should we be providing examples of how to do things in the correct way, so people
for sure
go on and produce the right content?
Yes, examples are absolutely needed. And also maybe examples on how to not do things.
Not to do things.
Right.
And yeah, definitely.
Thanks. Fede?
Yeah, I remember in the past, speaking about Arduino, we did this partnership with the Tembu. So if you wanted to have a secure connection with some services. So HTTPS, in order to manage HTTPS or OAuth, they were offered as a third-party service. But I remember a lot of people. So this took time in order to set in place and manage and maintain, and this maybe it's one of the reasons why it was not very well adopted by the users. So managing the encryption directly and in a very easy way. So like when you connect to a browser, so I admit I'm not a very expert about security. Maybe you can find some security holes in the test fixers. No, but when you the experience a normal user has on a browser, when you log to Twitter, Facebook, or other IoT services, you just put your username, you make a registration, you put username, password, and all the certificates are stored in the browser. They are completely transparent, and putting the same experience on a microcontroller would be maybe a key point.
Thanks. And okay, we're running out of time, so thank you everyone for joining us. I hope it was not too technical and you didn't fall asleep listening to us. So thank you so much for being here, and see you next year.